When we are steering the ship, let us observe our behavior. You all have been, steering the ship. Let us understand our behavior when we do the steering, what we are doing. Because understanding our behavior of how we are steering the ship will help us understand how the autopilot is functioning. So, for example, okay, autopilot is a system which is used for steering the vessel when there is no alteration of course required for a long period of time. The ship is continuing on the same course. Then we have already seen that we engage the autopilot and the ship is steering well. इधर जाता है उधर जाता है तो भी अपना course is maintained. So it is a device which is basically steering the vessel. Autopilot system is actually the brains behind steering. The steering system of the ship is separate and the autopilot system is separate. How is it? आपने तो देखा हुआ है कि सब एक ही जगह रहता है, उसे में सब रहता है. तो इंटीग्रेशन जरूर है. We are seeing one steering column and we have so many things there. उसमें रिपीटर भी होता है, जायरो रिपीटर. तो जायरो रिपीटर तो स्टीयरिंग का पार्ट नहीं है, वो स्टीयरिंग तो नहीं करता, उससे हम कोर्स देखते हैं. Then we have rate of turn indicator also there. Rate of turn indicator has nothing to do with steering. So everything is integrated into one, but autopilot system is a different system. Steering system of the ship is separate. In order to understand this, as we were saying, let us understand our behavior when we are steering the ship. Holding the wheel, master says, okay, come to 320. When you hear this command from the master, 320, what is your immediate reaction? One input already has come to you, 320. Immediately you look at the compass and see what I am doing right now. You see that you are doing, let us say, 280. So 280 to 320 you have to go. Immediately you calculate 40 degrees. 40 degrees to which side? I have to increase starboard. You also quantify in your mind how much this is 4 degrees, 40 degree, 40 degree, large alteration. Immediately you apply you of course repeat it to the master, give the confirmation, right sir, 320, and then you are turning the wheel to starboard. How much wheel did you turn? That depends on how much of alteration has to be done. 40 degrees of alteration. So it must be hard starboard. But this hard starboard, is it open sea for you? आप एक और input लेते हैं कि मैं खुले में हूं तो hard नहीं देना चाहिए. I have got enough room available, but you still give maximum that you can. Maybe 20 degrees, not 25, 30, 35, but maybe 20 degrees के आसपास आप दे देते हैं. So you are also taking visual inputs. As a human being, you are also taking visual inputs. What is the scenario like this? This input is not available for autopilot. So that's where we are better than the autopilot. Next, what is your observation? When you give this helm to the starboard. Your reaction, you keep watching the gyro compass now or compass repeater. Is it changing? Is it changing? Is it changing? Yes, now it is changing. Initially, what is your observation? That it is slowly changing. And so from 280, 282, 285, slowly it is increasing. And as the time is going, this swing goes faster and faster and faster. Rate of turn is increasing. So now you are cautious. नहीं ज़्यादा हो रहा है. You reduce the helm. When it is coming to 300, आप helm काफी कम कर देते हो. The swing of the vessel is taking it towards 310, 315 and all that. You are further observing that this kind of swing is going to overshoot the course. 320 बोला कप्तान ने, so it will go beyond that. So what do? We bring the ship to midship, I mean the helm to midship, and if required, we also bring it to, I mean give counter rudder to balance out, so that we try to stabilize the ship on 320. Meanwhile, when you are steering, do you have an input in your head? Okay, Anmol, आपसे question है ये, because these are the senior बंदों का discussion, आपसे से बात करते हैं. अनमोल साहब, how much of rudder you are giving? Has it got to play a role? I mean, is it going to be get affected by the loading condition of the ship? Do you consider the loading condition, how much of helm to give?
Yes sir, loading condition में भी देखते ही हैं sir.
Great. So please explain your behavior now that we were doing a 40 degrees of alteration and we are in a kind of, you know, not so open area, but ठीक है हमारे पास है area, खुला area है, but थोड़ा सा tight है, हल्का सा. तो what is your behavior?
सर जैसे घुमाना हो ज़्यादा तो फिर अभी ऐसे लोडेड कंडीशन में रहेगा तो हमारा टर्निंग सर्कल वगैरह बढ़ जाता है. तो फिर उस हिसाब से
ज़्यादा रडर देंगे आप?
यस सर, फिर ज़्यादा रडर देना पड़ेगा इन कंडीशन में हमें.
Okay. Now the same condition, loaded condition, your ship is doing half ahead. Does it play a role on your steering?
ये सर, क्योंकि पानी का जो फ्लो रहेगा वो भी तो फिर कम ही हो जाएगा ना हमारे, जैसे इन स्पीड्स पे डिपेंड करेगा ना. स्पीड जितनी ज़्यादा रहेगी उतनी स्पीड में हमारा शिप भी तो घूमेगा. स्पीड जब फ्लो ही कम रहेगा पीछे तो वो भी कम कर देगा उसको घूमने का.
Very good. That means speed also has got a role to play in your steering. The loading condition also has to play a role in your steering. The general behavior of the ship, whether fine form, full form, वो सभी चीज आपके दिमाग में रहती है. That means effectiveness of rudder कैसी है, उसके हिसाब से भी steering होती है. So all these inputs you are taking in order to steer the vessel. But when you are steering, मास्टर ने कुछ और बात कर लिया आपसे, कुछ और पूछ लिया, दिमाग भटक गया. नहीं सर वो तो ठीक चल रहा है, दोनों मोटर चल रहे हैं सर. उस समय स्टीयरिंग से आपका दिमाग हट गया, हालांकि वो दिक्कत नहीं होती. So as humans, we are also distracted from this point to that point. And what judgment we take in the same condition, what you take, what I take will be little different. आपने अगर स्टारबोर्ड 20 दिया था तो मैं हो सकता है 25 दूं. तो प्लस माइनस थोड़ा सा होता है ह्यूमन नेचर के चलते, ह्यूमन वेरिएबल्स के चलते. So we have an electronic device called autopilot, which is doing the same kind of job of steering the vessel. Remember that when we came to 320, now we are doing port starboard, port starboard, port starboard, and trying to continue on 320. We have stabilized the we have stabilized the ship on 320, one course given, उसके ऊपर चल रहे हैं। जैसे वो बाहर जाने को देखता है हम उसका उल्टा रडर देते हैं, वापस लेके आते हैं। जैसे इधर को जाता है तो हम वापस देते हैं। In doing so, we are trying to keep the vessel on a straight course. This autopilot system is an electronic and electrical combined system which is doing the same job, only little better than the humans generally. Also, it takes away the input of the humans for given condition, in a control condition, so that the job to be done by the navigator is just monitoring, not doing it, but monitoring. So this electronic device is doing the same kind of steering as the humans are doing, as you are doing, I am doing. The difference that it is maybe marginally better in a given condition only, not all the condition. Because remember, when I said the autopilot does not know how much sea room available, you know it. And because of that, you have already disengaged the autopilot and taken hand steering. What they say about autopilot system? Do not use in confined waters. Do not use it for collision avoidance and things like that, precautions, जो कि हम लास्ट में भी देखेंगे थोड़ा सा. So autopilot system is an electronic and electrical system which is steering the vessel on a given course. However, mode of operation, हम mode of ये देखेंगे, modes of autopilot system, तो उसमें और भी दूसरे modes हैं, we'll talk about that. But if it is electronic system, we all know in any electronic system, in a computer, you have to give input so that you get output. We are a computer system. We got the input, we got the input, we got the input, we got the input. What we call ज्ञानेंद्रियां, जिसे हमें ज्ञान होता है. नाक से सूंघते हैं, कान से सुनते हैं, आंख से देखते हैं, स्किन से टच होता है, जीभ से टेस्ट होता है. So these are sensors which are collecting information from the environment, and based on that there is an output coming from the processor, and then there is an action. कहीं गरम लगता है तो हाथ हट जाता है, सेंसर से इनपुट गया, दूसरा आउटपुट गया और हाथ हटा लिया कि भाई गरम है कुछ. Same way, autopilot also requires all these inputs. What inputs you had is also required by the autopilot system. So basically, an autopilot system is the brains behind steering. What you were doing, you were moving the steering wheel to operate the rudder. Thinking was done by you कि इतना देना है, इतना देना है, इतना लोडेड कंडीशन है, थोड़ा ज्यादा दूं, लाइट कंडीशन है, थोड़ा कम दूं, स्पीड ज्यादा है, आराम से चल सकते हैं, थोड़ा सा देने से. All thinking is done by the processor here. This processor work is done by the autopilot. And then it gives a command to a motor which operates the rudder, deciding how much to operate. So an autopilot system requires input, and two basic inputs required for that is the course that you are doing right now. Right now, that means gyro reading, and the course that you are asking it to do. So there is a course setting knob in the system. Either you are pressing it like this or it is protected some way कि गलत ना हो जाए, change ना हो जाए inadvertently. So you have a course setting control. You are telling the computer of the autopilot, I want to go 320. And as you are engaging the autopilot system, the brain starts working. So now autopilot is replacing you. So as you are engaging the autopilot system, it starts taking the input कि भाई आपका core setting कहाँ है 320. It sees where I'm right now 280. Then it decides how much of difference 40 degree, large alteration. Give lot of rudder. Once the rudder is given, then it is watching the arrow whether it is changing. Yes, it is changing. So till the time it is changing, the rudder is applied, and when it begins to swing, the ship begins to swing, then the rudder is reduced also. At one point of time, it is brought to 0 midship. अभी कोर्स आया नहीं है, 320 पहुंचा नहीं है, but midship आ चुका. And then further watching with rate of this, am I going to overshoot more than 320? Yes, then counter rudder also. So the autopilot system is doing all this thinking only since it is a computer, so the program is fixed. It is not getting distracted when the master is speaking or you are speaking to the autopilot. It does not listen to you because it has not been given an ear, another sensor to see what you are talking about. गूगल ने सेंसर डाल दिया कान में अपने, आप बोलते हैं तो खोज के बता देता है, बट ऑटो पायलट में ये सेंसर नहीं है जो आपकी बात सुने, बाद में आएगा तो मालूम नहीं. आप हो सकता है बोल देंगे कि ओके 320, तो हो सकता है आ जाए 320, मे बी ही स्टार्ट्स टॉकिंग टू यू लेटर ऑन, मे बी. So in steering, these are the considerations that has to be kept in mind. What course to do? What is the course right now? Comparison. Now when we are comparing what is happening in the system, मान लीजिए आपने कोर्स सेटिंग को कर दिया 320 पे, मान दिया आपने एंगेज कर दिया ऑटो पायलट. द ऑटो पायलट इज सेइंग that I am to go to 320. I am doing right now 280, so 40 degrees. This 40 degrees difference is converted into electrical voltage. To have a difference of voltage, you must have another voltage and this voltage so that they can be compared. So the autopilot system is converting the gyro reading into an electronic voltage. जो 280 है, corresponding to that there is a voltage electrical signal. The core setting knob, which is 320, is also converted into a voltage. These two voltages are compared together. A comparator is there. It compares the two voltages. If there is a difference, that means both are not same. That means there is, of course, difference is because one was 280, 320, so difference आएगा voltage में. This difference is known as error voltage. This error voltage can be positive or can be negative. अगर आपको उल्टा कर दें कि right now you are doing 320 and course to do is 280, तो इधर जाना पड़ेगा 40 डिग्री, तो वोल्टेज का पोलैरिटी अलग हो जाएगा, साइन अलग हो जाएगा. जैसे हम स्पीड में देखते हैं फॉरवर्ड शिफ्ट तो पॉजिटिव, वापस स्टर्न जा रहे होते हैं तो नेगेटिव स्पीड दिखाता है, ओनली डायरेक्शन चेंज. So here also port and starboard can be identified with the voltage polarity, which side positive, which side negative. And this difference of voltage, which is the error voltage, is also getting supplemented by another input which is coming from the rudder. दोनों का difference कहता है I have to give hard starboard 20 degree 25 degrees, So the rudder must go to 25, but rudder is already at 7 degrees. कुछ कर रहे थे, किसी मोशन में थे, किसी एक्शन के बीच में थे, रडर वाज ऑलरेडी एट 7 degrees स्टारबोर्ड. तो 25 जाने के लिए ओनली 18 प्लस करना होगा. So this 3 voltages, I mean these 2 voltages basically the course to do, course being done right now, the rudder input all put together are creating this error voltage, which is then amplified to a larger value. Design ka factor hai, it is amplified in something called error amplifier, and this voltage is given to a driving unit. Ultimately तो मुझको सिग्नल भेजना है रडर को नीचे है ना, स्टीयरिंग फ्लैट में. तो यहाँ के सिग्नल जो मैंने की वो तो यहाँ से भेजा था स्टीयरिंग से. Now it has to send the same signal. The autopilot has to send the same signal to the steering flat in order to operate the rudder. So there is a telemotor. This error amplifier is given to the telemotor. I mean, error amplifier output is given to telemotor, which is having 2 units, one in the bridge, other in the steering flat. इन दोनों के बीच में कम्युनिकेशन होता है, जो ये कहता है वो मानता है. So one is the transmitter, other is the receiver. Transmitter telemotor and receiver telemotor. Transmitter in the bridge, receiver in the steering flat. When the steering flat telemotor receives this signal, it further operates the hydraulic motors of the rudder. Hydraulic motors run करेंगे तो rudder will operate, or whatever kind of steering system is there, that steering system will be driven by that telemotor. So this is the basic of autopilot system. In theory, this is just what it is. The readings of gyro compass, the readings of course setting control are compared by means of electronic voltage. Difference is taken out. As per the difference, the rudder is operated. But did you see that we were thinking more than this? We were doing more than this. We were observing also that whether the swing is there or not. Autopilot also there. Checks it. What it is doing in checking? It keeps on watching कि 40 degrees का difference था, वो कम होना शुरू हुआ है, because the vessel has started swinging. So from 280 to 285, 290 जब हो रहा है, the difference is in reducing. When the difference reduces, the rudder also reduces. So there has to be smart thinking, as smart as you were doing. Same kind of smartness has to be shown by the autopilot also. If not, the vessel will keep on going like this. एक बार इधर को swing करेगा तो इधर rudder देगा, इधर को जाएगा तो इधर rudder देगा, इधर जाएगा. So it will be going like that. So efficient steering will not be there. In order to make that, we have to have a proper kind of system. So way back in 1917-18 only, they started this kind of system, autopilot system, so to say, but that was not efficient. Later on, improvements came. What we use on board ship now is to our standards quite advanced, very smart and intelligent systems. Yes, Anmol? Yes, Anmol? Okay, galti se hua. Somebody's microphone is on or what?
सर एक बार लास्ट वाला रिपीट कर देंगे, मैं लॉग आउट हो गया था वो नेटवर्क की इशू की वजह से ना, तो वापस लॉग इन कर.
So what we were saying, कहाँ तक आपने सुना था हमारा डिस्कशन?
वो जो डिफरेंस कंपेयर करते हो सारा तो सुन लिया था, अभी जो लास्ट के थोड़ा सा बचा था टेलीमोटर तक सुन लिया था, दोनों टेलीमोटर तक वो जो रिसीव था.
All right. So what we were just talking about is that this comparison is happening. So we have got this difference, but The autopilot system is not only about giving the rudder, but also reducing the rudder as per the requirement. So 40 डिग्री से जब वो 35, 30, 20, 20, 15 जब शुरू होता है, as the ship is swinging and the gyro reading is changing, going towards 320, तो डिफरेंस कम होने लगता है. डिफरेंस कम होता है तो एरर वोल्टेज कम होती है. एरर वोल्टेज कम होती है तो रडर कम ऑपरेट होता है. But we have already seen कि we also watch and we bring the system or rudder to midship even before we are coming to the set course by allowing the ship to go by the swing itself. Natural swing से जो चल चुका है उसका मोमेंटम जो है उसी के चलते वो जाएगा. और अगर हम लोग देखते हैं कि कुछ दिक्कत हो रही है, मतलब ज्यादा ओवरशूट करने वाला है, तो काउंटर रडर भी हम देते हैं. So all these functions are done by the autopilot. And lastly, what we were saying, that these systems were developed or started coming into the coming into existence way back in 1917, 1820 उस समय के आसपास. But during those times they were not so efficient. Electronics was not so improved. We did not have solid state devices like the semiconductors and all that, integrated circuits. These were not there. Computing was not so smart there, but now we have all that. So on the ship we have very smart systems now which can reduce our workload, steer the ship very efficiently, ultimately improving the fuel efficiency, which is the religion of any business. Spend less, earn more. So even when we are running the ship, we have to be as efficient as possible. जितना ज़्यादा speed बना सकें, जितना ज़्यादा कम fuel लगाएं. So all this exercise is going on in order to achieve that goal. Minimum expenses, maximum earning. Every business has the same rule. And we are all. अभी आप लोगों ने कुछ एक ये देखा था क्या? New technology to increase the speed of the ship and fuel efficiency increase के लिए देखा था? Have you seen that?
No, sir.
No, sir.
What they are doing, that they will have a compressor. That compressor will pump what? Air. But this air, where will it go? It will go under the keel. अगर कील ऐसे है तो यहाँ पे एयर के बबल्स होंगे. These bubbles are thrown into the water. So as the ship is going forward, let us say, the bubbles are always below the hull from the whole length of the ship. And because these bubbles are there in between, this creates less friction to the surface, and in effect what happens that it basically glides over those bubbles in a way. So new systems, compressors will be there, some jets will be there, which are constantly pumping the air bubbles into the water, creating a layer on which the ship is gliding. So different kind of systems being used. सुना है कि it's increasing the speed by 10%, 15% also. That's a big, huge saving. 10% saving is a huge saving. Think of the whole world, the 61,000 ships in the world which are flying right now. If everybody is saving 10%, big deal. Anyway, so we'll go to the slides, PPT slides, और उसमें देखेंगे. We'll talk about this, taking it forward on the slide. Why we said that their systems are smart now? Because not only these basic things are done, but there are smartness to be provided in the system to handle different kind of situations. So let me share the screen. Now that we have already discussed a little bit about this, I want you to read through the slides and see if it is appealing to you. अगर बात सब समझ में आती है तो. So here what we are looking at is an integrated steering system. Of course, we have the steering wheel. ये सब क्या बताऊं, लेकिन आपने देखा हुआ है. इसमें how much wheel has been turned is indicated here. Gyro compass repeater is here, and there are so many of controls. These, some of the controls will be related to autopilot settings. Some will be to only obtain information as to rate of turn, also may be integrated in the same system. You will have a display for rate of turn. And of course, you are more familiar than me about this steering systems. You have been handling this day and night now for so many years, so you are aware. So plain simple reading, just go through it and see if it is okay. जहां पे जरूरत लगेगी मैं अपना annotations दूंगा. Next, compass is giving us the current direction we are going in, so that is an information or input, all important input for steering कि मैं हूं कहां भी कहां जा रहा हूं. दूसरा information is that where I am supposed to go. Next, तो जो मैंने इतना टाइम लगाया बोलने में, ये 2 स्लाइड में खत्म हो गया. I think the slide is more efficient than me. I was just talking about efficiency. Next, anyone needing to ask a question, please do. When the gyro force has come to the course being steered, course to steer, जो करना था वहां पहुंच गया तो डिफरेंस 0 हो जाती है. So no input, no error voltage, and rudder is brought to midship. Next, basic तो इतना हो गया, but as we have seen that we had multiple stages of steering. एक कमांड के भीतर जो कैप्टन ने मुझसे कहा 320, तो there were stages of observation and action. First was immediate comparison of the two courses and immediate application of the rudder. So one stage is this. In the next stage, I am now watching how is the behavior of the ship. Is she turning? Is she beginning to turn? Then if she is turning, I also am aware, very much aware of the rate at which she is turning. अभी धीरे धीरे, अब तेज हुआ, अब आरओटी बढ़ा, अब आरओटी और बढ़ा. जैसे जैसे बढ़ रहा है, I am keeping an eye on that also. So that was the second phase when I am watching this. And as per that, I am changing the rudder, how much of rudder has been applied. If I see the rate of swing go high, I bring the rudder less and less. And in the final stages, of course, midship and then counter rudder if required. So all these different actions are to be performed by the autopilot, and so we have an overall control system of the autopilot, and that is what we are talking about, the control unit or control system of the autopilot. So different stages of activity are also categorized here. The control unit works in stages which are known as PID control system. P for proportional control. I don't know why. Integral second, and then D is for derivative control. So autopilot systems may be referred to as PID controls, PID autopilots. A certain type of autopilots may be called PID autopilots. Why? Because they have proportional control, derivative control, and integral control. The proportional control is the initial part of the steering action that we have seen. Derivative control is the second part of the steering that we have seen. What was the first part? Immediate comparison of the two courses. जितना ज्यादा डिफरेंस उतना उसके हिसाब से रडर अप्लाई कर दो. That means in proportion. ज्यादा डिफरेंस ज्यादा रडर, ज्यादा डिफरेंस ज्यादा रडर, कम डिफरेंस कम रडर. So the name here itself is indicating that it is the first phase of the action. Now that we have understood how it is working, so now we can relate it. Proportional control is in action during the early part of control. Derivative control is the second part in which we are observing the swing of the ship and making adjustments to rudder according to the swing. All right. So let us see what is proportional control. Before that, you should make this diagram, because sometimes they ask this diagram. The functioning of autopilot. So I would like you to make this diagram. One time making will also give you a little bit of practice and familiarity with the diagram. But what we have discussed is what is here. So please note down. Anyway, before you take down, let us understand what we have said. The autopilot system has got an input coming from the gyro. What is the course being done right now? Another input coming from the course setting control, जो आप देते हैं. When the autopilot system is on, there is immediate comparison between the two in the comparator. दोनों के बीच में comparison होता है. There is some more smart thinking inside the processor known as integrator and differentiator. These are methods of comparison basically. So not going into details of that. All this put together is coming to summing amplifier. Final summing यहाँ पे होती है. Net result आता है दोनों courses के बीच का, set course and gyro course का. Then it is coming to the error amplifier, where you are getting a feed from the rudder angle indicator. Rudder angle indicator कहाँ से मिलेगा इसको रीडिंग? वो मैकेनिकल लिंक से एक्चुअली मिलता है, उसी के थ्रू इसको हो जाता है. आप जब स्टीयरिंग करते हैं तो ऊपर वाली छत पे सामने में एक इंडिकेटर लगा होता है, where you can see where is the rudder position. So that is the mechanical link that we are talking about. So where the rudder is indicated in the rudder indicator ऊपर में in the bridge, and from there an input goes to the autopilot system, so that electronically also the autopilot has an input of the rudder position. All that given to telemotor, transmitter, telemotor receiver in the steering flat. This finally drives the steering gear pump or overall steering system, operates the rudder either port or starboard. जब ये होता है port starboard तो फिर से इसको पता चलता है कि किधर को गया, and then input is already available. So look at this, and if you have to, then ask some questions if at all. If not, please make the diagram. Are you doing it? Confirmation, please.
Yes, yes, sir.
Okay, okay.
सर ये कंपैरेटर के बाद इंटीग्रेटर और डिफरेंशिएटर एग्जैक्टली कर क्या रहा है?
Come again. Integrated.
यस सर, इंटीग्रेटर डिफरेंशिएटर का बता देना एक बार.
Basically these are all part of the smart thinking. Separately उसका हम अलग से नहीं बात कर रहे हैं, but it is all in the process of assimilating all the inputs. Not only input is comparator, but comparator के साथ integrator and differentiator, ये दोनों voltages को compare करने का process है basically. So separately what it is doing, we are not talking about it, but overall the integrator differentiator is all forming part of the comparator itself. Comparison happens by means of integration and differentiation, which is happening together at the same time. We are just saying that comparison takes place and there is an summing amplifier finally. So basically this much of part is all responsible for comparison. Then this part is the result, the output, and the output के बाद these are all actions. So sensors, you have gyro and set course, then thinking is done by this part, output comes, output is doing some action. Would this be okay, this answer?
यस सर, और ये सर RA इंडिकेटर कहाँ से?
रडर एंगल इंडिकेटर।
ओके ओके, थैंक यू।
यस, रडर एंगल इंडिकेटर जो शिप में ब्रिज में होता है, वो फिजिकल आप देखते हैं एक नीडल जो है इधर से उधर मूव करती है, जब आप पोर्ट देते हैं तो पोर्ट की तरफ जाता है, स्टारबोर्ड की तरफ जाता है, तो दैट्स मैकेनिकल इंडिकेटर। उसका एक इलेक्ट्रॉनिक इनपुट इज आल्सो गिवन टू द ऑटो पायलट।
सर इसमें इंटीग्रेटर और डिफरेंशिएटर का एग्जैक्टली क्या फंक्शन है?
I said that we are not discussing it separately, but it is all part of the, हमने तो सिर्फ बोल दिया ना जुबान में कि दोनों को कंपेयर करते हैं, एक लाइन में बोल दिया, but how much of algorithms are used for comparison are all very complex processings, all part of comparison only. So integrator, differentiator are basically part of the comparison process.
ओके सर।
एक लाइन अगर और बोलना चाहूं तो इंटीग्रेटेड डिफरेंशिएटर में there are processes of observing the rate of swing also, कि हमने इतना दिया है तो कितना हुआ, इतना करेंगे तो कितना होगा, अगर इतना रडर देंगे तो क्या रिएक्शन रहेगा, ये सब बहुत सारे प्रोसेसेस चलते हैं एक साथ। जैसे हमने कहा कि हम तो बोल के निकल गए एक लाइन में कि both are compared together, but it is not so simple. It is a complex processing which is happening in the computer system. So जो सर्किल बना के रखा है, कंपैरेटर, इंटीग्रेटर एंड समिंग एम्पलीफायर, all these are a part of comparison, all smart thinking, trying to apply different kind of controls, proportional control, the integral control, derivative control, सारे के सारे एक्टिविटी होती है यहाँ पे, सब सोचना ही है ना, all is thinking, all is processing of the data, so that is done at this place. Please tell me when you have completed. अच्छा, कुछ लोग और अभी कर रहे होंगे मेरे ख्याल से।
हाँ जी सर, कंप्लीट।
So we look at the PID system. As we said, PID stands for proportional, derivative and integral control. These are separate parts of the same complete processing. जैसा हमने अभी शुरुआत में बात करी कि इनिशियल में एक फेज ऑफ एक्शन होता है, फिर दूसरा फेज ऑफ स्टीयरिंग होता है। फर्स्ट फेज में हम देखते हैं कि कितना जाना है मुझको, दूसरे फेज में देखते हैं कि हम कर क्या रहे हैं, हो क्या रहा है मेरे एक्शन से, उसको ऑब्जर्व करते हैं। सो फर्स्ट वन इज द प्रोपोर्शनल कंट्रोल। The rudder is applied in proportion to the difference between set course and present course. More the difference, more the rudder. Less the difference, less the rudder. When this is applied, the vessel starts to swing. वहां पे derivative आएगा. But what do you think? If only proportional control was there, तो हमने 40 डिग्री पे मान लो 20 डिग्रीज का 20 रडर दिया. The difference was 40 degrees. We had to go starboard 40 degrees, alter by 40 degrees. then I give 20 degrees of rudder starboard. Proportional में होगा तो क्या? जब 30 difference आ जाएगा, that means the gyro course has come to 290, the difference is 30, that means rudder will be 15. When the gyro course is 300, difference 20, at that time rudder 10. 310, rudder 5 degrees. Similarly, when we are going, let us say, how much? 317.5 degrees पे आ गए, तो वैसे 2.5 degrees of rudder. Do you think the vessel will be controlled and will be steady at 320? Bringing the rudder to midship only when the difference is 0. Will that be okay? Can the vessel stay on, come and stabilize on 320?
कर जाएगा,
ओवरशूट कर जाएगा. सो ओवरशूट कर जाएगा तो दूसरी तरफ जाएगा, रडर दूसरी तरफ अप्लाई होएगा, उल्टा होएगा. फिर से वैसे ही आएगा, जब रडर मतलब डिफरेंस 0 होएगा तो रडर मिडशिप पे दूसरी तरफ फिर से शूट करेगा, ओवरशूट करेगा. सो दिस, if only the proportional control was applied, this will not turn out to be efficient steering. The vessel will keep on oscillating about the track, port and starboard of this. It will keep on making that snaky movement. It will keep oscillating about the course to steer. जहां जाना है उसके port, starboard, port, starboard, port, starboard होता चले. If only there was proportional control. Read the slide, please.
तो स्लाइड में कुछ दिख नहीं रहा,
कुछ नहीं दिख रहा है.
सिर्फ व्हाइट आ रहा है. अभी
ओके, वन सेकंड. अभी आया?
नहीं सर, अभी भी व्हाइट ही दिख रहा है.
यस सर, अभी
आया सर.
थोड़ा सा फेस डिफरेंस हो जा रहा है हमारे. व्हाट आर यू रीडिंग राइट नाउ?
नथिंग सर. अभी आ गया.
Are you seeing proportional control?
हाँ, अभी आ रहा है सर.
Okay. Now what are you seeing?
अभी आ रहा है. थोड़ा ब्लड है पर ठीक है सर.
वो ठीक होगा. Next. Are you reading? The rudder will be amidship.
Yes sir, it's clear now, but
ठीक है, वो थोड़ा बारिश हुई, उसमें लगता है कुछ नेट का भी दिक्कत है. So every time the ship is coming to the set course, then the rudder is coming to midship. But the ship was swinging at that time, and so she overshoots. So this is the result of the only proportional control. If you see here, only at this place when she is coming here is when the rudder is brought to midship. But at that time, the vessel was swinging to this side. It is brought to midship at this point, but the vessel was swinging to this side. So in doing so, she overshoots here, she overshoots here, and she overshoots here. So this will be the net effect of the autopilot if only proportional control was there. That means some activity has to take place at this place only, where the rudder should be brought to midship, allow the ship to swing because of her momentum. But since the rudder is midship, so the rate of turn will be slowing down. And when she is coming to the set course, most likely at this place, she will be stabilizing. Or if I am reading the rate of swing, then I can apply counter rudder also, which is what is done by the next, the derivative control. The derivative control is not looking at how much I have to go, what I am doing. There is no comparison between where I am right now and where I have to go. The comparison is between where I have to go and what I am doing right now. These kind of activities are taking place by those integrators and differentiators. The smart thinking of the autopilot is done by those things. Here the rudder is changed as not for the difference between the set course and course to steer, but seeing the behavior of the ship, how the ship is swinging, rate of swing. If
Sir,
the rate of swing is more, then the rudder applied is less. If the rate of swing is less, the rudder applied is more. So in the initial part of the action, when the autopilot is engaged, the derivative control will be in action. But as the ship is beginning to swing, the derivative control is pushed back. The proportional control is pushed back. Derivative control comes into action. It takes over the control of the rudder. And the rudder is reduced or increased as per the rate of swing of the ship.
sir, time हो गया sir.
Time ho gaya? Okay, good. All right. So anyway, we have to continue this class. The next class is also ours, but nonetheless. So we had seen already here. Okay, let's go. So what happens at some point before only it is brought to midship? The ship is allowed to swing by her momentum. Also, an eye is kept by the system on the course to steer, jahan pe jana hai hame, and how much is the swing. Comparison is made, smart thinking is done, and if required, counter rudder also is applied here. What happens when she is coming like this? She is settling on the course. She had gone out of the course, corrections was done, and she starts running parallel to the track that we have laid down. So the course to steer was this. It had gone off course, initial part proportional, then as she is turning like this, at this point midship, the vessel keeps on swinging, and then finally she comes and settles on the course. So this is the result of the derivative control and proportional control combined together. Third part is the integral control. This integral control is basically a correction to constant change of heading because of parameters of the ship. The hull construction, the type of bow, transverse thrust, which you are, I suppose, aware. When the propeller is turning, she is not only propelling the ship forward, but the pitch angle of the blades are also pushing the water sideways. In doing that, the stern starts to go in opposite direction. What we are trying to say is that when the propeller is turning, let us say this direction, so ship is going into the screen. Suppose we are watching from the stern and the ship is moving forward into the screen. The propeller turning like this also pushes the water which is here. She is pushing it this side. So in turn, the stern will go to the port side. That means turning will happen to the starboard side. Transverse thrust it is called. Because of this, there is a constant change in the heading, which we have already seen in the ship. When we are steering, we see that every time the ship is going a little off course. And so to do that, to control that, what we do, we apply, either we set a new course, थोड़ा सा offset course दे देते हैं. अगर 320 पे जाना है तो 322 323 कर देते हैं कि उधर को स्टेयर करेगा तो 320 पे चलेगा. या तो वो कोर्स सेटिंग में ही कर देते हैं अपना, और नहीं तो अदर मेथड इज दैट वी अप्लाई अ permanent helm. When we apply the permanent helm, again going back to the screen, the ship going forward for right-handed screw has the tendency to go to port side. So what we do in permanent helm, we apply little bit of rudder to the starboard. So this movement is neutralized by this movement, and so the ship will go forward in a straight line. Integral control is responsible for this permanent helm. So 2 degree, 3 degree, 4 degree जो भी है, which is necessary to control the constant movement of the heading to the other side, is controlled by the permanent helm. So some bit of it is adopted by itself, but we also have our own input. We have manual control also for permanent helm. We'll see all the controls that we have available at our hand. अगले चैप्टर में देखेंगे. But the integral control reads the behavior of the ship, how she is behaving. Is she going again and again to one side? On the basis of that, the system will apply a permanent helm. Now, when permanent helm is applied, this becomes midship. मान लीजिए कि अगर आपने सिस्टम ने परमानेंट हेल्म मान लीजिए 3 डिग्री का दे दिया. So this 3 degree starboard is now already or acting as midship 0. So 5 degrees to starboard will take it to 8 degrees starboard, and 5 degrees to port will take it to 2 degrees port, because 3 degrees are already here. So from midship, from here, 3 plus 2 5, or 3 plus 5 8. So this midship, this permanent helm, whatever the position, begins to act as a midship. ऐसा नहीं कि रडर एंगल इंडिकेटर में भी 0 डिग्री आ जाएगा, नहीं, वो 3 डिग्री दिखाता रहेगा. But for steering purposes, this will be treated as midship. So this is also done smartly by the system. It senses the heading error over a period of time. बार बार वो चेक करता है कि क्या चेंज हो रहा है. If it is observing that every time the ship has a tendency, then it will apply permanent help. So altogether, proportional control, derivative control, integral control, all are combined together. The three sides of the brain working together, coming out with one response. That one response is finally driving the rudder. So इतना सारा सोचना होगा तो कहाँ होगा? There has to be some complex thinking. All that is done in that part. Not integrated separately, but combined, which is comparator, integrator, differentiator, summing amplifier, सबको मिला करके all this is done together. This type of rudder, as we had initially seen, is called PID autopilot. Mostly what we find is PID autopilot in the ships. So are we clear about PID system?
Yes.
Yes.
And the basic principle, how the autopilot steers the vessel. So these are the this is the basic functioning of it. But let us come to a situation, taking the topic forward. We put some more inputs. Again, you are steering. आपने मुझको बताया था, अनमोल साहब ने बताया था कि डिपेंडिंग ऑन द लोडिंग कंडीशन ऑफ द शिप आपका स्टीयरिंग पैटर्न बदल जाता है. When ship is light, one way of steering. When the ship is loaded, तो स्टीयरिंग का पैटर्न बदल जाता है. तो क्या ऑटो पायलट सिस्टम का ये नहीं बदलना चाहिए अलग अलग कंडीशन में? क्योंकि जहाज का बिहेवियर, रिस्पॉन्स टू रडर has already changed because of loading. That has to be accommodated. Another thing, the speed is doing 7 knots. The style of steering at 7 knots and style of steering at 17 knots are entirely different. हाई स्पीड में चल रही जहाज, आपको थोड़ा सा टर्न देना है, आप 2, 4, 5 डिग्री का रडर देते हैं, उतने में जहाज घूम लेता है, because she is moving at high speed. But she does not respond to your 5 degrees of rudder when she is doing 7 knots. So you have to give 10 degrees in order to make her respond to your command. So in different situations, the rudder type of the type of steering that you are doing or style of steering is changing. Now how does the autopilot know? हमने proportional दे दिया, reference ले लिया हमने course setting से और current course से, but ये loading का condition ये कहाँ से आएगा? ये speed का condition कहाँ से मिलेगा उसको? How will she efficiently steer this? That means she needs this kind of inputs. If the autopilot wants to, is supposed to steer nicely, then these parameters must be given to this. So in order to make the autopilot work optimally at the best possible steering output, you have to provide certain kind of inputs to the autopilot. You have to do some settings manually. By doing this manual adjustments, you are giving right kind of inputs, instructions to the autopilot system so that the autopilot is able to steer the vessel efficiently. For example, take another case. You have to give a large alteration. You are giving hard port, मान लीजिए. So someone give me an example. When you give to hard port, what is the rudder angle that you go to?
35.
35. But is only 35 allowed, or there is more possibility of going further? रडर और जा सकता है आगे कि नहीं? 35 से ज्यादा, 37, 38, 40?
37 तक
जाता है, बट आप लेके जाते हैं वहां तक?
No, sir.
No, sir.
Very often you have an instruction from the master. When I say port, hard starboard, don't go beyond 30. He will have his own reasons. He does not want the rudder to get stuck, so he is keeping it at 30. So उन्होंने एक लिमिट डाल दी है. Anybody who is steering, never go beyond this. Verbally बोल दिया, command दे दिया कि don't go when I say hard starboard, hard port, 30 से ऊपर मत जाओ या 35 से ऊपर मत जाओ. Same kind of command can be given to the rudder also. Autopilot also. That means when the rudder is thinking I have to give hard port, hard starboard, you can set a limit for the rudder. Yes, you can set the rudder limit. The autopilot system will never go beyond that. आपने 20 degrees का डाल दिया, the autopilot system will never take the rudder more than 20 degrees port or starboard. So these are some of the controls that we have on the autopilot panel. These are user controls. Now I have got a great problem with this autopilot topic, which not so much is a problem in phase 2, but is a huge problem in second mates. Now what is that? Controls of autopilot and control unit of autopilot. There is always a confusion. When the control unit is asked, they start writing about user controls. When they are asked about controls of the autopilot, they start writing about PID system. Of course, it is confusing to some students, cadets, like उनके लिए थोड़ा सा confusing हो जाता होगा. So I try to bifurcate these two by a word user control and control unit. But examination में मैंने नहीं देखा user control. What are the controls on the autopilot panel? What are the controls provided? This is how they ask. So this has to be clearly understood that there are user controls which we have to set as operators. As navigators, we have to provide this settings, and within these settings, the system will steer the vessel. So autopilot is coming into action when one of the two situations are developing. या तो मैंने कोर्स सेटिंग चेंज कर दी, 320 से आगे चला गया, पीछे चला गया, फिर से डिफरेंस क्रिएट हो जाता है, या 320 पे ही है, and there is a wave coming which has taken my heading to let us say 300. तो हेडिंग चेंज हो गई, जारो का रीडिंग 300 पे आ गया, फिर से डिफरेंस आ गया, So the autopilot will start acting. So another advanced, before we go to that user controls, another advanced version of PID system is known as adaptive autopilot. PID system में तो हमने देख लिया, but there is another advanced version which is known as adaptive autopilot system. But anyway, before we go to that, let us one second. Okay, yes. So we'll come to the adaptive autopilot once we have done the user control. Sorry, there was some confusion in my mind. So what are the user controls, as we refer to it as controls on the autopilot panel? 10-12 number का question भी होता है ये. First one is the course selector knob. We know what it is. This is the knob which is provided to tell the autopilot that this is the course that I want to do. In our examples that we are talking about, 320. So in some of the autopilot systems, it may be digital. You can input a number, or so very often you have a knob in the center of the repeater जिसको आप पुश करते हैं, टर्न करते हैं और रिलीज करते हैं तो वो वापस पॉप कर जाता है. स्प्रिंग लोडेड knob is there. That spring loaded knob is specially designed as per IMO requirements, that the course setting has to be such that it cannot be changed inadvertently. By mistake, it should not be changed. A deliberate action is required if you want to change it. आप स्टीयरिंग कॉलम के ऊपर ऐसे कोने लगा के खड़े हैं, हाथ से छू गया और जाना था जापान, पहुंच गया चीन. So it should be protected against inadvertent changes. So this special arrangement is made where you have to push the knob down, turn it, release. When you release, it will lock onto that place again, as per IMO requirements. If it is digital, then also there has to be some kind of safety measure so that these numbers cannot be changed. आपने 32 डाला है, so it is protected unless you want to change it deliberately, then you have to do some action. So course selector knob. There is another control provided for permanent helm. Like we have seen, बहुत लोगों ने, आप लोगों ने यूज तो नहीं किया है इसको. अगर बार बार शिप ऑफ कोर्स जा रही है, ऑफ ट्रैक हो रहा है, तो आप ऑटो पायलट में सेटिंग चेंज कर देते हैं. 320 जाना है, 320 जाना है तो 322 कर दिया, 323 कर दिया. 3 डिग्री के ऑफसेट पे है तो 320 पे चलेगा. बट you are also provided with a knob or control from where you can set the permanent helm. So in addition to the ship autopilot system, you have a manual control also. You can neutralize the constant effect of ship going off course by a control knob called permanent helm. Especially handy in case when there is a crosswind or other kind of drifting is there, तो इसको हम यूज कर सकते हैं. Third input is the speed input. The steering behavior of the autopilot should change at different speeds, and so the speed input may be given to the autopilot system. Of course, there is a lot of integration on the ships nowadays. So this input is coming from the speed log. You don't have to, mostly you don't have to change this. So speed input is coming from the log directly, but it may be possible that there is no interface provided, and so for the given speed you must provide a number to the system. You have to enter the speed, 6 knots, 7 knots, 8 knots, 10 knots, and basis this 8 knots, 10 knots, the steering behavior will change. So the common understanding that we know, okay, one thing, this is speed input. Which log it is coming from, Doppler log or EM log?
Doppler.
Okay, Doppler. Let me change the question, because the new batch, they have not done EM log or Doppler log separately. So my question will be rephrased. Is it speed through water or speed over ground that we should give for the autopilot? Doppler log आपने कहा मोहित, तो I am understanding that you are saying speed over ground that we should provide. Is that correct?
Yes, sir. We put speed over ground.
Okay, speed over ground. Anyone else? What kind of speed input should be given to the autopilot system? Anyone? Don't make me wait for so much.
Speed through water, STW.
Okay, so we have a contest here. More votes.
It should be speed through water, sir, not speed over ground.
Yes, it should be speed through water.
On the rudder to autopilot, उसके हिसाब से फिर करेगा तो speed through water.
Exactly. Because when the ship is being steered, there is water flowing in the reverse direction. When the rudder is turned like this water hits the rudder, and in turn the stern will go here. The ship will turn to this side. If there was no speed through water, that means this water is not there, then there is nothing hitting the rudder which will cause the stern to go this way or that way. मान लीजिए जहाज खड़ी है, इंजन बंद है, ship is floating, and there is a current of 3 knots. तो speed over ground तो आ जाएगा, 3 knots से बहने लगेगी जहाज. But if you turn the rudder at this time, no action will take place. Only wind वगैरह के चलते जो change हो गया, different windage available on the ship, उसके चलते कुछ change होगा तो होगा, rudder से कुछ ना होना. So it is speed through water that should be provided to the autopilot system. Next, rudder control. Ship is doing 320, all right. By some reason she has gone 2 to 3. I mean 3 to 3. 1 degree, 2 degree का change हुआ. How much of rudder should be applied? Should I apply a hard port, hard starboard for slight change in the heading? No. For this small change, I should apply only, let us say, 3 degrees of rudder, because it is just shifting from the heading. तो 3-4 डिग्री का दे दिया, 5 डिग्री मान लो, 5 डिग्री दे दिया, बहुत है. To control the ship when she is going off heading, we were doing 320, it has gone to 323, 2-3 डिग्री shift हुआ. How much of rudder should be applied is set by the user. हम यहाँ set करेंगे 5 डिग्री. But then again, if the ship was loaded, इस 5 डिग्री में रिस्पॉन्ड नहीं करता जहाज इतनी आसानी से. So what I should do to control that heading? Okay, मैं 7 डिग्री से 8 डिग्री रडर कर देता हूं, तब अब जहाज कंट्रोल में आएगी. नहीं तो एक बार अगर हिला बाहर और 2-4 डिग्री 5 डिग्री का रडर दिया तो रिस्पॉन्ड ही नहीं करती जल्दी. So this rudder control is the amount of rudder to be applied for slight bit of change in the heading. सेट कोर्स से जहां चेंज हुआ तो रडर जो अप्लाई करना है कितना करना है, that can be set by the navigator, and this one particularly deals with the displacement of the ship, whether loaded or light condition. लाइट में वैल्यू कम रहेगी, लोडेड कंडीशन में ज्यादा रहेगी. Also, this will decide the behavior of the ship. अगर लाइट कंडीशन में ज्यादा रख दिया तो थोड़ा सा हिलाने कि ज्यादा रडर अप्लाई हो जाएगा, तो करेक्शन तो होगी और ओवरशूट कर जाएगा दूसरी तरफ. So this will keep on happening. It will result in inefficient steering. So it should be optimally adjusted for the loading condition and seeing the behavior of the ship. So this is rudder control. The amount of rudder to be applied for a slight bit of change in the heading or deviation from the set course. So this may be little bit of hit and try learning for the navigator, because हर जहाज का रिस्पॉन्स अलग होता है, अलग अलग कंडीशन में रिस्पॉन्स अलग होता है. तो हो सकता है कि you have to learn yourself, familiarize yourself how is the behavior of the steering, and accordingly एक दो झटके के बाद उसको सीख सकते हैं. Again, there is a limit of counter rudder. The autopilot system, the PID system, wants to apply rudder, counter rudder. How much? The limit can be set by you. The correcting helm, counter rudder, should be applied by the amount set by you. अब काउंटर रडर में आप हार्ड पोर्ट हार्ड स्टारबोर्ड तो नहीं करते नॉर्मली, वैसे करते भी हैं डिपेंडिंग ऑन द सिचुएशन. कन्फाइंड वाटर्स में ज्यादा पड़ सकता है जरूरत, बट नॉर्मली ऑटो पायलट हम खुले स्पेस में यूज करते हैं, खुले एरिया में. So we can provide the limit for the counter rudder. Again, if less counter rudder given, overshoot will be more. अगर ज्यादा काउंटर कर देंगे तो हो सकता है कि कोर्स के आने के पहले ही रुक जाए. So again, this should be optimally adjusted so that counter rudder is able to balance out the overshoot and not stopping it from coming to the set course itself. Next, yaw control. Now, what is yaw? Supposing you are steering, manual steering, hand steering. There is rough weather. In the rough weather, the ship is getting subjected to the elements, the wind, the sea, the waves, swell, etc. They are constantly changing the heading of the ship. एक बार starboard 10 डिग्री चला जाता है, एक बार port 10 डिग्री चला जाता है. So there is constant changing of the heading. What is your opinion? Since you are steering manually, will you not try to give the rudder in such a way that minimum overshoot is happening? जो 320 जाना था वो 330 नहीं जाए, 310 नहीं जाए, जो बार बार इतना चेंज हो रहा था. If I keep on operating the rudder properly, trying to keep the ship very close to 320, will it not result in proper steering? That means ETA will be good, distance covered will be better, fuel efficiency will be better, because distance less, the fuel efficiency also good. So should we try to control the ship from, the oscillating from the main heading? How should we steer? Your input, please. सब सो गए.
No, sir.
अच्छा, ओके, तो ये भी बताया जाए थोड़ा. हाँ, जग तो रहे, तो बताइए क्या करना चाहिए. बैड वेदर में जहाज आपका खिलौने की तरह हो रहा है, उसकी हेडिंग इधर से उधर हो रही है. Should you try to keep it straight by operating the rudder so that she is not oscillating so much?
यस सर.
सर बैड वेदर में सर रिलैक्स्ड रहता है सर, तो जाने देते हैं उसको थोड़ा थोड़ा.
सर ज्यादा रडर देने से और स्ट्रेसेस पड़ेंगे और इफेक्ट ज्यादा होगा.
That's the point. हाँ, बोलिए, go ahead.
सर रडर लिमिट कम कर देंगे सर.
रडर लिमिट तो अलग चीज है. हम तो योगी, अभी तो हम ये बात कर रहे हैं आपसे कि आप मैनुअल स्टीयरिंग कर रहे हो, आपका क्या बिहेवियर होगा, आपका क्या सोचना होगा. अभी ऑटो पायलट आपकी खोपड़ी में लगा हुआ है, तो आप कैसे स्टीयर करेंगे, वो पूछ रहा हूँ.
सर होता क्या है कि जब बैड वेदर में आप यू कैन नॉट यूज टू मच रडर, बिकॉज जब विंड वेव्स के इफेक्ट से बाव जब स्विंग करेगा, वी कैन नॉट कंट्रोल दैट विद रडर अलोन. It's too difficult, so we should to give allowance to let the bow swing around 3-4 degrees from the set course.
Great, that is what I wanted to hear. मुझको एक इनपुट मिली थी कि हाँ, हम ऑपरेट करेंगे रडर टू कीप द वेसल ऑन स्ट्रेट कोर्स. What will actually happen if you apply the rudder too much? Actually, there is a resistance which is the rudder is providing to the water, or water is providing to the rudder. So although there is a sideways movement, there is one component which is stopping the vessel also. Application of too much rudder, when there is a force being acting, okay, if on this surface there is the water which is hitting, this water is producing two kinds of component. One component is this side and the other component is this side. So it also stops the speed. I mean, it also cuts down the speed to some extent. Too much of rudder will result in less speed of the ship. So very rightly said by so many people, and people who had little bit of a doubt about this. Too much of rudder application will curtail the ship speed, will result in inefficient use of the fuel, more consumption, ETA will become poor. So what we should do, because we cannot control the heading, so we allow कि भाई इतने दूर के बीच में तुम नाचना है तो नाचो, उससे ज्यादा दूर जाओगे तो मैं कंट्रोल में आऊंगा. So what you are doing, you are opening up the yaw control here. You are opening up the yaw control. If the heading is within this limit, the rudder will not operate. Only when the ship is going out of this, यहाँ पे अगर जाने लगेगा तो rudder apply होगा. Now that it is going to port, so the vessel will be turned to starboard by applying starboard rudder. So this is called yaw setting, ki how much of change of heading is allowed before the rudder is applied. So naturally in good weather this limit will be very minimal. In good weather, no waves, nothing. So we don't want the ship to go beyond any heading, I mean a small range. But if the weather is bad, no matter what I do, the ship heading keeps on going from here to here. So I open the yaw setting कि भाई घूम लो, जितना नाचना है नाच लो, इस बीच में rudder will not be applied, because when she is coming here at this port side deviation, the waves will take it to this side again, then again to this side. So allow it to happen. So yaw control should be narrow in good weather and should be wider in bad weather. 2, 4, 5 डिग्री हम अलाउ कर सकते हैं बैड वेदर में, 1 डिग्री 2 डिग्री रख सकते हैं गुड वेदर में. Then there is rudder limit. This was the command of the master, which I said never go beyond 35. You can also tell the autopilot never go beyond 20. So that's the maximum. That's hard port, hard starboard for the autopilot. Since you have set the limit to 20 degrees, the autopilot can never go beyond 20 degrees. So this is the limit. Even when you are altering course using the autopilot system, like for example that we have been taking in all discussion that we are having. So 40 degree को भी अगर alter करना है मुझको from 280 to 320, then the hard rudder which is applied by the autopilot will never go beyond set limit. अगर आपने 10 डिग्री पे रख दिया तो 10 से ज्यादा नहीं जाएगा. She will try to turn the vessel at maximum rudder of 10 degrees only. And so depending on how fast your requirement of the control is, you have to change the setting. It may be more, it may be less, but smart thinking, and you can set this limit as per your requirement. Then there is another another control, which is off course alarm. You all have used it, you all have seen it. Can somebody give me some insight into this particular functionality? Yes, sirs. ऑफ कोर्स अलार्म हम कब यूज करते हैं, कैसे यूज करते हैं?
The alarm is set, it's preset value, whatever we set it. If in case whatever heading we have preset, if the course this autopilot heading goes beyond that set value, say 4 degrees or 5 degrees, then it will give alarm. It can happen due to effect of current or some other factors.
So in the given condition that we discussed, you had to go to 320. आपने autopilot engage कर दिया. While setting the course to do, course setting को आपने 320 पे रखा, autopilot on कर दिया. इस समय कोर्स था 280 और आपने 5 डिग्रीज का या 3 डिग्रीज का ऑफ कोर्स अलार्म लगा रखा है, तो क्या अलार्म बज जाएगा? बिकॉज डेफिनेटली 40 डिग्रीज अवे फ्रॉम सेट कोर्स और लिमिट है 3 डिग्रीज का आपने डाल रखा है, तो क्या अलार्म बज जाएगा?
No, sir.
Nahin. So what happens? You're right, and what you said earlier also was right, but then there is also a time delay. क्योंकि अगर सेट कोर्स पे आना है तो एक्शन लेना होगा, एक्शन लेना होगा तो टाइम देना होगा, वेसल को टर्न करने का भी टाइम देना होगा. So what happens in this case, that the vessel will operate the rudder, will try to bring the vessel on course, but if it is trying and trying and trying and then not able to bring the heading to set value, तो एक टाइम के बाद वो हाथ खड़े कर देता है कि भाई ना हो रहा हमसे. That means rudder is applied, it should have come. अगर वो स्विंग करना शुरू कर देता है तो चुप रहता ही है, अलार्म नहीं बजेगा. हाँ भाई चल रहा है ना, अभी जाना है 320 पे, सो स्विंगिंग, वी आर गोइंग क्लोज 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 क्लोज. लेकिन अगर उसने रडर दिया और स्विंग हो ही नहीं रही, और हो रही है इतनी धीरे धीरे कि एक सेट टाइम के बाद बाहर निकल गया, then of course alarm will come. So there is also a time delay. A time period is given to the autopilot system during which it is trying to bring the vessel on course. अगर उसमें फेल हो जाता है, उस टाइम के बीच में नहीं ला पाता है, then it will raise the alarm. So you can set the value कि कितने हेडिंग के बाहर अगर वो रह जाए और भीतर ना आ सके उसके, आपने मान लीजिए 3 डिग्रीज का सेट किया हुआ है ऑफ कोर्स अलार्म, 320 में 323 एंड 317 के बीच में अगर नहीं आ पाता इन given time, then it will sound the alarm. This of course alarm is also handy in knowing the failure of steering system. Autopilot is working good, it is giving command, but the rudder is not operating, something has gone wrong. Rudder not operating one way or the other, तो जहाज कोर्स पे आएगा नहीं, कोर्स पे आएगा नहीं तो अलार्म बज जाएगी. So this of course alarm can be used for the two purposes. एक तो for self monitoring of the course, that we are doing the right course or not, are we going out of the course by so much as per set value. Also it can be an indication for the steering failure, and so this of course alarm should be established that it is working. It should be tested once in a while that it is working. तो पोर्ट में हम कर दे सकते हैं ऐसा, जब जेटी पे लगा हो जहाज, हमने कोर्स सेटिंग थोड़ा सा दूर कर दिया और गेज कर दिया ऑटो पायलट, रडर घूमेगी, जहाज बंधी हुई है, जहाज का हेडिंग चेंज नहीं होगा, जहाज अलाइंड विद द जेटी ओनली. सो इमीडिएट अलार्म नहीं आएगी, पहले वो रडर देगा, फिर कोशिश करेगा करेगा करेगा, नहीं होगा, then alarm will come. As we have seen earlier, weather also has a role to play in the kind of setting that you will have. So of course alarm is also set for wider angle in bad weather and smaller narrower angle for good weather. Then there is another control called synchronization control. आप सब लोगों ने मल्टीपल टाइम्स प्री डिपार्चर चेकलिस्ट बनाया है. One of the point in the pre-departure checklist is synchronization of all the repeaters with the gyro compass. So we have the gyro compass at the bottom. The steering column is this. Gyro is here. On what we see here for steering is basically the repeater. We have a repeater on the starboard side also. We have it on the port side also. Bridge front पे भी है. So all are repeaters. The steering is done with this repeater only. The autopilot is not looking into gyro reading. It is looking into autopilot is reading the repeater reading. जो कंपैरिजन सारे हो रहे थे सब रिपीटर के रीडिंग से हो रहा था. So it is important that the gyro must be synchronized or repeater should be synchronized with the main gyro. Gyro की रीडिंग जो है what force is being done is normally digitally shown below the steering column. 8 सेगमेंट्स का डिस्प्ले नॉर्मली होगा और जो जायरो कर रहा है the master gyro is given in digital form and the same thing should be appearing on the repeater compass card. For this you are provided with a button called synchronization control and you have all used it on board ships. आप जायरो की रीडिंग देखते हैं, स्टारबोर्ड पोर्ट सही है, हाँ इतना डिफरेंस है, ओके चलेगा, नहीं ज्यादा हो गया, इसको कम करो. So you are aware of that setting of the synchronization control, I mean use of the synchronization. Another one is the steering selector switch. What kind of steering you want? तो ये स्टीयरिंग कॉलम में ये आपके पास प्रोवाइडेड होता है. There are 3 positions minimum: auto, follow up, non follow up. There may be a 4th position also in this called adaptive. But we are talking about these 3 which are basic and everywhere available in all autopilot systems available. The auto is basically autopilot when you are wanting to run it in PID mode. That autopilot system is working. If not, then you are manual steering, hand steering में. So in hand steering it is basically the follow up mode. That means rudder follows you. What you do on the steering control, the rudder will go behind you always. आपने starboard 10 किया, rudder starboard 10 पे. आपने 5 डिग्री बढ़ाया, starboard 15, rudder starboard 15. You come to midship, पीछे वो भी midship पे आ जाए. You go port 7, rudder port 7. So it is following you. It is following the steering wheel. Another one is non-follow-up, which you are aware of. In the autopilot system column, there is a tiller provided for operating it. It is spring-loaded, which you can turn it left and right, port starboard. This is a joystick type, spring-loaded, so you can push it to this side. जब यहाँ पे होगा तो rudder will start going to the port side. When you leave it, it will come back to its original position. यहाँ पे आ जाएगा, but rudder will remain at this place only. क्या हो गया? Rudder will remain here only. जहाँ पे आपने, जब तक आप इसको इधर को रखेंगे, rudder जाता रहेगा. जब छोड़ देंगे, it will remain there itself. It is not following you. When you turn it to starboard, the rudder will start going from here on. From here it will go to starboard. अभी midship पे नहीं आया है, इधर आना शुरू हुआ, आप छोड़ देंगे इसको, यहीं पे रुक जाएगा. So that you have already seen. It is called non-follow-up NFU control because it is not following you. Basically what it is another method of steering where the command is given from here directly to the steering flat. बीच में टेलीमोटर ये सब वो सब सारी चीजें वो सब खत्म हो जाती हैं. अगर कुछ इलेक्ट्रॉनिक फॉल्ट आ गया, कुछ दूसरे तरीके का फॉल्ट आ गया, So parallelly, there is another connection which is going directly to the steering flat, and you are operating the steering flat motor from the bridge itself. You are all aware that this is used as a steering failure control or emergency steering के लिए. I hope everybody has used this. Most likely you have.
Yes.
Yes.
Yes, sir.
Of course. So emergency steering, do we use only this, or there is another method also for emergency the steering?
तो स्टीयरिंग थ्रेड से करते हैं सर जाके.
Yes, the phone control. Basically, from the bridge you are giving a command over the phone. Somebody listens to you. और वहां खड़े होकर के करते हैं. अगर NFU का भी कंट्रोल बीच में अगर गड़बड़ हो गया, यहाँ पे डिस्कनेक्शन हो गई, कुछ ये वाला भी नहीं चल रहा, तो सीधा आप फोन से बोलते हैं स्टीयरिंग फ्लैट में, और वहां पे कोई दूसरा थर्ड इंजीनियर खड़ा होगा, वो ऑपरेट करेगा. आप बोलेंगे पोर्ट 10 तो वो पोर्ट 10 पे लेके जाएगा, आप बोलेंगे स्टारबोर्ड 10 तो स्टारबोर्ड 10 पे लेके जाएगा. So that is selector switches. Then finally, yes. Somebody's microphone. किसी का माइक्रोफोन ऑन है भाई? अच्छा, हो गया, ठीक. Final is the dimmer light, जिससे आप रीडिंग करते हैं द कोर्स की. That is controllable brilliance of the light depending on the ambient light available in the bridge, what you want to see, whether you are able to see or not. कम ज्यादा कर सकते हैं. Illumination of the panel can be changed with this. Almost all equipment जहाँ पे लाइट है उसपे में सारा में लगा होता है, चाहे वो GPS का हो या इको साउंडर का पैनल हो, रडार का पैनल हो, सब जगह ये ब्रिलियंस होता है. So these are the user controls. Now I am very much aware that you would be thinking कि हमने तो इतना सारा कुछ किया नहीं जहाज में, ये क्या क्या बताए जा रहे हैं. We have always used auto pilot में डाला और जहाज चल पड़ी, है कि नहीं ऐसा? कितने लोगों ने सेटिंग्स किए हैं?
सर करे हुए हैं सर.
करते हैं सर, वो डिपेंड करता है.
अरे वाह, good to know that. Yes, good to know that you have done it. Probably this class will help you understand what you are doing and what is your expectation from that. या तो आप ऑलरेडी जानते हैं और नहीं तो कुछ और आइडिया लगा होगा, हो सकता है डिस्कशन में.
PID कंट्रोल का सर पता नहीं था, पहले देखा जरूर था पर मतलब इतना क्लैरिटी नहीं थी, वो अभी पता लगा. बाकी तो सर ड्राफ्ट मोड, स्पीड सेटिंग और हेवी वेदर सेटिंग ये सब तो सर करते ही हैं. सिर्फ PID का सर इतना क्लैरिटी नहीं था.
हाँ, तो अभी आपने एक बोला हेवी वेदर सेटिंग. ये सेटिंग में क्या करते हैं
सर? हेवी वेदर मोड होता है सर, बस ऑन ही होता है उसमें सर.
हाँ, तो जानते हैं उसे क्या होता है?
सर वही योइंग जो आपने बताया, योइंग का लिमिट बढ़ जाता होगा.
सारे सेटिंग्स जो है ये प्रीसेट वैल्यूज दे दी गई हैं आपको. ये मैन्युफैक्चरर भी समझते हैं भाई इनसे तो ना होगा इतना सारा सेटिंग, 10 सेटिंग, कंट्रोल मतलब रडार लिमिट इतना करो, काउंटर इतना करो, ये उतना करो. तो उन्होंने एक ही प्रीसेट वैल्यू दे दिया है. ओके, हेवी वेदर, तो उससे सारे सेटिंग्स जो हैं अकॉर्डिंगली चेंज हो जाएंगी मोस्ट लाइकली. सो गुड वेदर, हेवी वेदर का मोड दे दिया या फिर ऑफ कर दिया तो नॉर्मल मोड में, ऑन कर दिया तो हेवी वेदर मोड में. सो वेदर कंट्रोल स्विचेस, उसमें भी यू हैव समटाइम्स नॉट ओनली ऑन ऑफ स्विच फॉर वेदर, बट वेदर में भी 1 2 3 4 की सिलेक्शंस होंगी, है?
जी सर, होती है सर. और प्रिसिशन भी रहता है, प्रिसिशन 1 2 और इकोनॉमी.
एग्जैक्टली, प्रिसिशन एंड इकोनॉमी वो भी बात करेंगे हम लोग आगे बात करेंगे. इकोनॉमी एंड प्रिसिशन मोड, बेसिकली ओपन वाटर स्टीयरिंग एंड कन्फाइंड वाटर स्टीयरिंग की बात हम करेंगे उसमें. तो वो भी दैट आल्सो वी विल डिस्कस इन द नेक्स्ट क्लास. बट हियर व्हाट वी आर सेइंग, वेदर में 1 2 3 जो रहता है that is basically for gradations of bad weather is given. थोड़ा खराब, moderate, moderate से थोड़ा ऊपर, बहुत ऊपर, तो you can select level of bad weather. And according to bad weather level, आपके ये जो सारे कंट्रोल्स हमने बात किए अभी तक, वो सारे ऑटोमेटिकली प्रीसेट वैल्यू में चले जाएंगे, so that individually you don't have to set each one of them. One click, weather 2, सारे settings as per new conditions are set. So what you were saying, economy and confined waters, that is going to come, but we'll discuss that in the next class. For now, we are done. So have a great evening, all of you.
हाँ सर,
थैंक
एक
यू
क्वेश्चन,
सर।
एक डाउट
नो
था
सर।
हाँ बोलिए डाउट पूछा।
सॉरी सर, मैं पहले पूछा नहीं सर। ये ऑफ
थैंक यू सर।
कोर्स सलाम में जो आपने बताया, ये टाइम डिले जो होता है कि उसका कुछ सोलास रिक्वायरमेंट है क्या? लाइक ऑटो पायलट कितने देर में इट शुड गिव ऑफ कोर्स सलाम, और इट शुड थिंक कि चलो अभी ये टाइम है, आई शुड ट्राई, ऐसे कुछ करके
आई थिंक
उसका कुछ मतलब
वैसे तो मैंने आपको, आई डोंट रिमेम्बर सीइंग दिस. I am a performance standard for the auto pilots. I don't remember seeing this, that it should come to that course within certain time. मान लीजिए
एटसी मैंने भी सर ट्राई किया है, बहुत बार टेस्टिंग करी है, तो उसमें कभी 30 सेकंड, कभी 40, कभी 45 सेकंड पे भी आता है, और मतलब ऑफ कोर्स सलाम, मतलब ऐसा कुछ फिक्स नहीं होता कि हाँ एक बार एंटी हेल्प दे दिया तो आ ही गया।
नहीं, ऐसा नहीं होगा. मान लीजिए आप वेसल को टर्न करना चाह रहे हैं ऑटो पायलट पे, कांस्टेंट आरओटी की वैल्यू आपने दे दी, और आप ये 80 डिग्रीज का ऑल्टरेशन कर रहे हैं. यू आर डूइंग ऑल्टरेशन ऑफ 80 डिग्रीज यूजिंग ऑटो पायलट. तो मान लीजिए कि यू आर डूइंग 100, नाउ यू वांट टू गो टू 180, 180. अब 100 से 180 जाने में लंबा टाइम लगेगा या नहीं?
करेक्ट।
ऑटो पायलट चल रहा है, स्विंगिंग चल रही है, धीरे धीरे चल रही है, सब कुछ सही है, कोई दिक्कत नहीं है, लेकिन वहां जाने में इतना टाइम लगेगा कि नहीं?
हाँ उतना तो लगेगा सर, पर प्रैक्टिकली लाइक अब जहाज पे लिमिट हमने 10 डिग्री देके रखा था ऑफ कोर्स का, 15 डिग्री तक का ऑप्शन था शायद, तो उसमें 20-25 डिग्री हमने दिया था, तो आई डोंट थिंक 20-25 डिग्री में ज्यादा टाइम लगेगा पानी में।
नहीं, जो आपने लिमिट सेट किया वो ये कि अगर आपने मान लीजिए 10 डिग्रीज का लिमिट दिया, सो सेट कोर्स एट 10 डिग्रीज और इसके बीच में अगर नहीं आता है इन ए गिवन टाइम, देन द अलार्म शुड बी साउंडेड. जैसे फॉर एग्जांपल जो हम लोग बात कर रहे थे, 180 पे जाना है और ऑफ कोर्स अलार्म आपने 10 डिग्रीज का रखा है, तो 170 से 190 के बीच में अगर नहीं पहुंचेगा वहां तो अलार्म बच जाना चाहिए. लेकिन यहाँ से 100 से 180 जाने में टाइम लगेगा ना, उसको
टाइम तो लगेगा,
टाइम लगेगा, तो उतने देर में नहीं पहुंचेगा तो अलार्म बच जाना चाहिए. बट एवरीथिंग इज फाइन हियर. So I don't remember seeing the time actually कि how much time, but then जो ओवरऑल फंक्शन है उसके बेसिस पे मेरे ख्याल से मैन्युफैक्चरर सेट करते हैं कि हाँ अगर सब कुछ स्विंग हो रही है, सब चल रहा है तो ठीक है. अगर हेडिंग चेंज नहीं हो रही है, रेट ऑफ चेंज नहीं आ रहा है रडर देने के बावजूद, तब ऑफ कोर्स अलार्म आ. चलो बाय बाय, हैव अ ग्रेट डे ऑल ऑफ यू. A circuit, electronic circuit, basically it receives input and it gives output. Output is to drive the rudder. Input is from the gyro reading and from the core circuit. So this is the basic, but it is not so simple, as straightforward it is not. There are many complicated things inside, of course. So one next level that we saw, that if you want to operate the autopilot in an efficient way, if you want to work it at optimum level, the steering has to change as per the behavior of the ship, given the ship condition or given the weather conditions, whether may wind, crosswinds, or currents and all that. seeing all these parameters, the style of steering should change. Autopilot would not know what to do all by itself. So there are some controls provided that we set as per the prevailing conditions. Prevailing condition, that means the speed of the ship, the loading condition of the ship, etc. Also seeing the weather, external conditions, whether there is a wind, whether there is current, that is, the ship is going off course again and again. So basis that we are provided with certain kind of controls. These controls help the autopilot operate in optimum way. So a block question: what are the controls provided on the autopilot panel for optimizing its use or for optimum performance? So now you are knowing that there are some 11 controls that we have seen yesterday: rudder limit, rudder control, counter rudder, permanent helm, of course alarm, dimmer, the mode selector, auto, NFU, etc. Those kind of things, synchronization control, etc., etc. So these are user controls, and these are two different kind of questions. I'm repeating once again. The control unit is the brains of the autopilot that we are talking about, how it does, and controls on the panel, controls on the autopilot panel are the user controls that you adjust for different kind of steering pattern that you want. But one level better, because advancement is happening all the time. So one level better is something called adaptive autopilot. Adaptive autopilot is basically replacing or eliminating the need of adjusting all these controls. Why? Because we are giving the input to the setting the parameters for the autopilot for a given condition. Why? Because the steering behavior changes. I give this much of rudder, sometimes it turns faster, sometimes it does not turn faster. So actually हमने ये जो parameters set किए, it was on the basis of behavior of heading change or heading control. There are some new part added to the PID system. A new circuit is added. This circuit is called estimation algorithm. There is certain kind of software system which is added to the PID system, and to this system there are inputs coming. One, that what is the action taken by the PID autopilot? I have given this much of rudder, so input goes that the rudder is so much, and then in turn it sees the behavior of the heading also, whether the ship is changing fast, changing slow. So that change also is coming as an input. Based on this, that if I give this much of rudder, the ship is not responding. So there is another estimate that, okay, I should do more. So rudder is increased. Like you would do, आपने starboard 5 दे दिया, जहाज नहीं घूम रही है, तो आप 7 करते, 8 करते. क्यों? क्योंकि आपने एक तो रडर दे दिया, देख रहे हैं कि 5 दिया है, और देख रहे हैं कि जहाज नहीं घूम रहा है. दो इनपुट हो गए आपके दिमाग में. तो ऑन द बेसिस ऑफ दैट यू डिसाइड कि नहीं, आई शुड गिव मोर. दिस जॉब इज डन by the autopilot, this adaptive system. This thinking is done by this estimation algorithm, added component to the PID system. That means it is adapting to the steering pattern of the ship or steering behavior of the ship. If there is crosswind, there is constant change of the heading. It reads that I am keeping mid shape, it is going off course. So accordingly, it will adjust. This estimation algorithm, there are many types basically, but something which is used is called Kalman filter. Kalman was again a scientist, an innovator. So he designed this circuit in which there are estimation of a variable behavior, like the heading of the ship, based on different inputs. ये अगर ये किया तो क्या होगा, ये किया तो क्या होगा, ये किया तो क्या होगा. So there are inputs coming कि रडर एंगल इतना है, इतना है, इतना है, इतना है, अलग अलग इनपुट देते हैं. इसके बेसिस पे ये रिजल्ट हुआ तो आगे करेंगे तो क्या रिजल्ट होगा. That smart thinking is done by the autopilot. So in adaptive autopilot, you don't have to do all these settings. The system, the autopilot system will adapt to situation. अगर स्पीड कम है, जहाज रिस्पॉन्ड नहीं करता जल्दी, तो इट विल रीड कि मेरे थोड़े से देने से नहीं रिस्पॉन्ड कर रहा तो मुझको ज्यादा देना. या तेज चल रही है जहाज, लाइट है, थोड़ा सा देने से ज्यादा स्विंग होना शुरू होता है, तो देखता है कि नहीं थोड़े से देता हूं तो स्विंग होता है जल्दी जल्दी, तो थोड़ा कम दो. So all that is adjusted automatically by the autopilot. This Kalman filter, although it is used in autopilot in recent days, I mean, okay, काफी दिन हो गए फिर भी, but it was invented way back in, the 60s के आसपास. And this Kalman filter and this algorithm, estimation algorithm, is not only used in ship autopilot, it is used in so many places. So many places. The guided missiles that they travel, उसका हेडिंग इधर को होएगा मिसाइल का, तो वापस करेक्ट करके सीधा करेगा, नहीं उधर जाना. You have cars, self-driving cars, they take input from the dotted line of the road. वो अगर लेफ्ट को जाएगा तो नहीं, लेफ्ट को जा रहा है, थोड़ा सा स्टीयरिंग इधर करो. So that auto steering of the car also using this kind of estimation algorithms. अभी एक नया गाड़ी आया था ना, किया का या किसका एड आती थी, क्रूज कंट्रोल and this and that. So ad used to come. They are also using all this kind of system. Robotics में use होता है. You have seen, probably you have seen some robots which are, if you push them, they will correct themselves. They will not fall. You think कि एक रोबोट को धक्का दे देंगे तो गिर जाएगा, नहीं, उसमें एक जैरो लगा हुआ है. जैसे ही वो तिरछा होता है तो लगता है कि मैं इधर जा रहा हूँ, तो सीधा करता है, एक्शन दे करके वापस करेक्ट करता है. सो देयर आर रोबोट्स जिसको आप धक्का मारोगे तो गिरेगा नहीं, वो जैसे आदमी बचने की कोशिश करता है अपना सेंटर ऑफ ग्रेविटी, वैसे ही. So that is anyway added thing. So we'll take a look at the adaptive autopilot, and then we look at the key points that we must consider and keep in mind when using autopilot system. Autopilot system is not just on off. When we use an equipment, we have to apply mind how to get best output of this. What are the constraints in which it is operating? What are the constraints in which I am operating? So सारे चीजों को assimilate करके, and then we take certain decisions कि इसको चलाना चाहिए, नहीं चलाना चाहिए, कैसे चलाना चाहिए. So that smart thinking has to be there. Let me go to the slides और वहीं से बात करेंगे. We'll make a block diagram, simple block diagram of the adaptive system. कि उसमें process क्या है. So let me go to the slides. Okay. So auto adaptive steering system, as we said, extension of the PID system. It adapts to the situation. It adapts to the steering behavior of the ship. Given certain kind of action, certain kind of response of the ship, all are taken as input. मैंने क्या किया, क्या हुआ. Then estimation कि ये करूंगा तो वो होगा. So over the period of time, these observations are made. And then the action or behavior is predicted for a given action. As we said, this is an added feature to the PID system. PID वैसे ही काम कर रहा है, लेकिन उसके साथ एक ये addition कर दी गई. I think most of you must have seen a control provided on the autopilot or steering column where it said PID and adaptive. देखा है आप लोगों ने, किसी ने? Yes, gentlemen.
No, sir.
Yes, sir.
Okay.
Yes,
so,
sir, देखा sir.
Exactly. So now you know what is adaptive system. In normal PID system, you have to adjust the controls manually. In adaptive system, you are allowing you are taking the help of the autopilot itself to adjust itself. तो उसमें bad weather, good weather, ये सब वो सब जो है सारी settings होती रहती हैं. In fact, even when there is yaw, bad weather, तो अपने आप वो अपना wide कर लेगा yaw control. अपने आप wide कर लेगा. You don't have to. If it is PID system, you have to do. If it is adaptive, then it will widen because it will see that I'm giving rudder, nothing happens. The ship is still doing this course, heading is changing constantly. So it understands that, okay, weather is bad and the ship, no matter what, the waves are throwing the head to this side and this side of the course. So it sees that there is no point steering right now. So let us widen it. So some of you have seen it, some of you have not. Probably who have not seen was not installed with that kind of recent or this advanced system. But yes, there are adaptive systems also. So there will be a knob showing PID and autopilot. Adaptive. So you can use the autopilot in both the modes depending on your choice, depending on your comfort level with the given choice that you have. There are features available. Some people are happy with one feature, other people are happy with other feature. There is no comparison. If this is better, this is better. It is up to the individual who is feeling better with one thing. And it should be that way. And it should be respected कि हाँ मुझे ये पसंद है, आपको वो पसंद है. So it must be good for you. This is good for me. We are both aiming for the same thing: safe navigation, efficient navigation, good ETA, fuel consumption reduction. दोनों का अप्रोच एक ही है, मतलब एंड रिजल्ट एक ही है, अप्रोच अलग है. So what we call is the estimation algorithm. Because of this, all the controls are readjusted automatically. Not by you, but by the system. So optimum steering is obtained without you changing any setting. Why? Because the settings are changed by the ship itself. I mean the autopilot itself. So what we call this Kalman filter, this is basically that added circuit. Filter is filter के नाम पे हमें दिमाग में चाय का फिल्टर ही याद आता है, मुझको आता था हमेशा से, फिल्टर है तो वही फिल्टर कर रहे हैं, but these are filters for electronic circuits, inputs and outputs. So the basic function of Kalman filter is this. Provides estimates of some unknown variable given the measurements over time. So there are unknown variables or measurements over time are basically the rudder given, and unknown variable what will happen to the heading. So अलग अलग टाइम पे अलग अलग इनपुट्स आ रही हैं, हेडिंग चेंज हो रहा है, हाउ इट इज हैपनिंग, तो further estimation is provided कि if I do this that will happen. Next, this explains what we have been talking about. If you see here, there is preset course जो आपने course setting दी है. The autopilot system may be operating in course skipping mode और course changing mode, जो अभी हम बात करेंगे आगे. या तो आप turn कर रहे हैं using autopilot, or you are going straight course using autopilot. So there is a choice that switching can be done, whether it is course change mode or course skipping mode. All that PID system and all that we have seen will ultimately lead to this steering gear. Control is given, command is given to the steering gear, rudder operates. When the rudder is given, it is operating the rudder, and the rudder is producing certain kind of behavior of the ship. The heading changes, but changes this way or that way, कभी ज़्यादा कभी कम. So ship का dynamics तो है अपना, उसके चलते response बदलता है. External disturbances हैं, उसके चलते भी बदलता है. All put together, what is happening to the heading is given the feedback here, और यहाँ से इसको फिर से जाता है. What to do? Seeing the behavior of the ship, yeah, okay. This feedback is again given to this. So how to steer, keep the course is getting guided by how the heading is behaving. So in general, this is what is adaptive autopilot. Any questions? I would want you to make this diagram just for the understanding sake. What is the process followed by an adaptive system? Please make this diagram, adaptive autopilot. Or would you want to also see the slides once again, the text?
ये सब दिखा दी.
Okay, so we go back here. Adaptive system. Just go through the slides once again to reinforce your understanding. थोड़ा सा कहानी है, थोड़ा सा सारा कहानी है, स्पेसिफिक तो कुछ नहीं है, nothing technical about it. We are just knowing the general behavior. Next. Salient points अगर आपको नोट करना है तो नोट कर सकते हैं, if you are making the notes. जो खास पॉइंट है you can note down, like estimation algorithm, Kalman filter, what it does. Next. So end result, basically what we want is improved efficiency of the steering system. How do I get best steering? Best steering means controlled movement, better fuel economy, better speed, that's all. Next. All right. Next.
Yes, sir.
Next. 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 So you can make this block diagram. Probably आपके notes में नहीं होगा. इसको आप यहाँ पे जो नीचे ऑटो पायलट 1 लिखा हुआ है, इसको आप लिख सकते हैं मोड 1 एंड मोड 2। हो जाए तो बता दीजिएगा। Finished?
Yes.
तो वेट कर रहा था मैं.
Yes, sir. हो गया.
Okay. So just to sum it up, finally, one thing that we have to see that the ship's heading, as we have already said, is giving the feedback to the initial part of the system. Also, what is the gear doing is also given to this. So there are two inputs which is guiding what to do next. स्टीयरिंग गियर ने क्या किया है, रडर कितना है, उसके चलते शिप की हेडिंग कैसे चेंज हो रही है. बोथ इनपुट्स आर यूटिलाइज्ड इन गिविंग द फर्दर कमांड, नेक्स्ट कमांड, व्हाट टू डू. So we go to the modes of autopilot. We haven't got much text written here, so we'll just discuss it. Of course, you have seen probably on the autopilot that there are two modes. One mode is course keeping mode, the other one is course change mode. These are the two modes in which the autopilot system can be utilized. As the name indicates, course keeping mode is when you want to go on a straight course and the steering has to be just about maintaining the course. You're going straight. We have already seen how it is going to work. PID system, adaptive system, all that we have seen already. So course keeping mode and course change mode, the other name as it is indicating, you can use the autopilot system for making alterations also. When you want to alter course, let us say from 015 to 085, so there will be an initial course and there will be final course. The vessel has to turn from here to here. She will take a curvature. The path taken by the ship will be along arc of a circle. Later on, for the new boys, it will be later on discussed, but just talking about this, we can turn this vessel by two methods, either keeping the rate of turn constant or by keeping the radius constant. So what we do in autopilot, we just provide what is the ROT that is required. In the autopilot system, we set the course to 085, the course to do, course to steer. Right now the course is 015, of course. So we are setting where we have to go, 085, and we engage the autopilot in course change mode. The autopilot system will apply the rudder and it is now going to watch this required ROT, which you have specified as 7 degrees per minute. So it will apply rudder slowly so that the ship is beginning to turn. She is turning at a given rate. When that rate comes to 7 degrees, it will stabilize that 7 degrees by reducing, adding, subtracting the rudder. So it will keep on maintaining this 7 degrees per minute. And of course, it will watch the heading from what to what to what it is happening. When it is coming to 085, that's where the rudder will be removed and she will try to stabilize the ship on the new course. So these are the two modes when we want to go straight, the course keeping mode. When we want to turn, the course change mode. Another mode or the two types of course keeping mode you are seeing is open sea mode and confined water mode. This open sea mode is normally also known as economy mode. Because we are in open sea, we are assuming that we have wider space available. थोड़ा सा इधर थोड़ा सा उधर होएगा तो कोई प्रॉब्लम नहीं है. So in this case, the autopilot is little liberal or laid back in operating the rudder. The rudder is not very often operated. थोड़ा सा प्लस माइनस अगर हेडिंग हो रही है तो होने देता है. It applies the rudder little sluggishly, धीरे से, आराम से. Why? Because this gives us better speed. If we keep on applying the rudder, then it cuts down the speed of the ship. And so in open sea mode, the rudder is not applied so very often. So it is allowing the ship to continue, move on with slight bit of heading change also, no problem. थोड़ा ज्यादा बाहर जाने लगता है तो ऑपरेट होता है. But this liberty is not available to you in confined waters. You are going in a traffic lane. You are in areas where lot of deviation or some deviation of the course is not allowed, no room. In that case, you are coming or operating the autopilot as confined water mode. Here, the steering is very strict. Slight bit of change of heading and the rudder will operate. It will not allow the heading to deviate to any extent. I mean, as far as practicable, it will try to keep that heading very, very constant, even when even by applying the rudder, and even at the cost of little reduced speed. Here we are not looking at the economy. Here we are looking at the safety. So we can select this kind of modes, which mode we want to operate in. This is our choice. Whether I am sailing in confined waters, how do I want my ship to sail? Confined waters or open? Open sea में economy mode, confined waters में confined mode. Do we have other kind of names for this kind of modes on the ship? Autopilot में आपने अगर देखा हो तो इकोनॉमी का तो मुझको पता है. दूसरा क्या होता था?
Precision.
Precision. Okay. So confined water is basically precision mode. Very good. So economy and precision is basically what we have here, open sea and confined water modes. And we also see that autopilot can be used for large alterations also by means of course change mode. But as far as practicable, these large alterations in confined waters should be avoided. It should be done manually by hand steering. वो हम precautions में देखेंगे. What are the precautions to think of when we are using autopilot for steering? Another mode which you may find on the ship is weather mode. So there can be a switch or a switch provided by the name of weather control, and there will be numbers 1, 2, 3, 4. That is required, or that is basically the preset values of various controls which were provided for you to change manually. जो हमने देखा था rudder limit, counter rudder, permanent helm, ये सब वो सब जो देखा था. As we have already understood that this have to be adjusted for different kind of situations. So in bad weather, the behavior of the ship changes. So we have graduation of bad weather, very bad weather, or moderate, or good and very good weather. So for those kind of situations, we have this weather switch. जिससे मैं सेलेक्ट कर सकता हूँ प्रीसेट वैल्यू ऑफ ऑल द कंट्रोल्स. आई डोंट हैव टू adjust all controls one by one, but just by changing one mode, all settings are done as per this kind of it. But changing to this does not negate your responsibilities of monitoring. You as an officer on watch are always responsible for safe navigation. Not the autopilot, not the radar, not the GPS, nothing is responsible. You are responsible for safe navigation. So monitoring or good practices of bridge watchkeeping has to be maintained at all times. So any inputs on the modes of operation? कुछ और आप लोगों का experience रहा है? Something that you want to add in this? Something of your experience?
सर
Yes.
ये ऑटो शिप्स में जो ऑटो पायलट आता है उसमें सर 2-3 मोड होते हैं. एक तो होता है नॉर्मल मोड जो एक हैंड होता है, दूसरा ऑटो और दूसरा एक नैव कंट्रोल जो नॉर्मली ट्रैक इन सिंक विद टैगडिस होता है, जो कोर्स होता है उसको मेंटेन करता है, लेट कोर्स.
Exactly. So that is added up.
हाँ सर, तो उसको हम लोग यूज नहीं करते क्योंकि एक बार फर्स्ट शिफ्ट पे हुआ था कि वो रात का वॉच था, हम लोग बात कर रहे थे ब्रिजविंग पे और अचानक से शिप जो है घूमने लगा. इट वाज लाइक द रडर वाज हार्ड टू स्टार्बोर्ड 35 डिग्री. जाके चेक किया तो नैव कंट्रोल में था और हमें पता था कि नैव कंट्रोल में, तो उसको ऑटो पे डाला और फिर उसको पहले हैंड पे लेके स्टैटिक है, फिर ऑटो पे डाला और कैप्टन को बताया कि ऐसा ऐसा. तो फिर उसके बाद से हम लोग वो यूज नहीं करते.
Okay. All right. So there was something gone wrong. Now, as we are talking about these modes, here we are talking about course keeping mode and course change mode, whatever. So what we are saying actually, if the course that we had to do, this one, and the ship is actually on this course, do you think there will be an alarm given by the steering system? Are you on the same course? जो ये आपने चार्ट पे डाला था, this is the okay. Let us change. The orange one is charted course. The ship is doing the whatever course that you can see. Do you think the ship is happy? I mean, the autopilot is happy. जो आपको मुझे बोला गया मैं कर रहा हूँ.
क्रॉस ट्रैक एरर है ना सर, तो वापस जाओ.
क्रॉस ट्रैक एरर है, but course keeping mode, I think the ship is maintaining the course.
Yes.
So it does not have any problem. The ship is going to do this course because आपने कहा हुआ है, looks like to me 06050 degrees. तो 050 degrees ship भी कर रहा है. There is no problem. But we have GPS on board ship. When the autopilot system and ECDIS system and GPS all are integrated together, on the chart, this particular point has got a lat long, right? Any point on the chart is having a coordinate. This course that is made up of latitude, series of lat longs, and that is coming as a straight line. The ship is having its own position. The ship is having its own position because of GPS fix, and the chart is having this track in terms of coordinates. So the ship's position is compared with these positions of the course. If this position of the ship is matching with this, then she is on track. If the ship's position is not matching with what is the track lat longs, the charted course का lat long से नहीं मैच कर रहा है, then there is an alarm. So what we have been actually talking about is course control, automatic course control, जिसमें 050 the ship is doing, it has got no problem. But when GPS is included in the system, integrated with it, it is not only comparing the gyro course and the course setting course to do, but it also sees where I am right now and where I was supposed to be. So on the chart you have made multiple points, lat longs. सारे ये dotted line जो आप देख रहे हो स्क्रीन पे, these are separate coordinates, and if you join them together it makes a course. So जहाज अपना position check करेगा whether my position is matching with these or not. If it is matching, you are on track. If it is not matching, you are away from the track. Then you can decide how much difference is allowed, cross track error is allowed. So if the ship is here, no problem, because it is within limits. But if she is going out, way out, more than what limit you have set, if you have set the limit, you should remain within this line. 2 cables to this side, 2 cables to that side. If the ship is within this, it is all right. If she goes out, then there is an alarm, off track alarm. So on the ship, we have this course control mode or course control system, or we have track control system. These are two different things. Course control mein we just watch what heading I'm supposed to do, what I'm doing right now. It has got nothing to do with position. But in track control system, the nav mode, what you said, also includes the input of the GPS. And the ship's GPS position is compared with the charted positions that you are supposed to follow. Of course, there is some kind of error which has taken place. वो hard port starboard कर रहा था आपका system, and you did not use because you lost confidence कि नहीं ये nav mode में सही नहीं कर रहा है, so we will not take risk. Stop कर दिया काम करना. You must have reported to the company also. They might look into the matter. They will talk to the company, provider, manufacturer of the autopilot. What has happened? They might sort it out later on. Maybe you are aware, maybe you are not. हो सकता है कोई और आपके रिलीवर्स वगैरह के साथ ये सब एक्सरसाइज होगा.
सर इसमें सर पैरामीटर्स बहुत ज्यादा आ जाते हैं सर, कि कितना तेज घूम के वापस ट्रैक पे लाएगा, कितना रडर लाएगा सर, वो सब सेट सारा सही होगा तो सर सही काम करता है. मैंने भी एक्सपीरियंस किया था सर, हार्ड ओवर दे के वापस ट्रैक की तरफ एकदम 90 डिग्री एंगल बना के सीधा तुरंत ट्रैक की तरफ जाना शुरू कर दिया. तो सर वो इसलिए फिर सर उसकी लिमिट दी है कि कितना मैक्सिमम एंगल देगा रडर का, या क्या कोर्स कितना रिलेटिव डिग्री ऑफ अप्रोच रहेगा टुवर्ड्स द ट्रैक. सर ये सब सर डिफरेंट इसमें मतलब ट्रैक कंट्रोल में सेटिंग्स आ जाती है.
एकदम. So you see, familiarization with the system is necessary. You can use the things smartly if you know about it. If you are having a total command over the system, you can make it work for you. If you don't know, you are not aware, तो दिक्कत हो सकती है. जो हार्ड ओवर हो सकता है, मोहित आप कह रहे थे ना हार्ड ओवर वाला केस.
सर वो हम लोग ट्रैक पे थे, फिर भी दे दिया था इसलिए.
अच्छा, ओके, सो हो सकता है. So what we just heard, for one reason or the other, this was the track. The ship was here somewhere. nav mode में आके उसको देखा कि मैं दूर हूं, तो इतने हार्ड दे दिया कि सीधा ऐसे अप्रोच करेगा ट्रैक की तरफ, which is not of course not right. So it should have gone straight slowly and जाकर के मिलना चाहिए था अपने ट्रैक पे. So of course, so now you understand of course कि what is the importance of knowing the system. And let me give an advice. Read the manuals. जितने इक्विपमेंट हैं उनके मैनुअल पढ़िए, टेक आउट सम टाइम, अगर ब्रिज में है, यू आर फ्री, जस्ट पुल आउट द यूजर मैनुअल. There is lot of information available. Once you are gone through this, you automatically become a confident person because you know about. अगर नहीं जानते तो हाथ पैर फूल जाते हैं कि क्या करूं, लेकिन if you are knowing कि अच्छा this is how it works, ये करना है, वो नहीं करना है, क्यों करना है, if you are aware of all this, then you don't have any problem. You can make the system work for you. So pull out all the manuals one by one. ठीक है, I can understand कि बहुत काम होता है, ये होता है, वो होता है, but when you are in the bridge and you are navigating, keep your watch properly. But then we all know from practical life कि हाँ थोड़ा सा हम 2 मिनट बैठ भी सकते हैं, देख भी सकते हैं, वॉच करते के साथ. So use that time to educate yourself about these things. You always become a confident person, a better officer, better navigator. So we have seen these modes of operation. Very good input. Navigation mode. So course keeping mode हो गया, course change mode हो गया, weather mode हो गया, nav mode हो गया. Course keeping mode में we have open sea mode or economy mode or confined waters mode, which is basically precision mode. So अलग अलग मैन्युफैक्चरर अलग अलग नाम दे सकते हैं, ले दे करके सबका फंक्शन वही होगा. So adaptive देख लिया था. Now we'll jump over to some precautions. Okay, so what we do, 5 मिनट पहले छोड़ रहे हैं, 5 मिनट पहले आइएगा, because now we are going to start new subtopic.